Hey guys, this is a quick review on how to graph lines, and this is a topic that you saw in your previous algebra classes and again in your geometry class last year. So we're going to focus on graphing lines in slope-intercept form and also vertical and horizontal lines for now. So just a quick recap. Y equals mx plus b, that is slope-intercept form of a line. M is your slope, also known as your rate of change, also known as rise over run. And then the b is your y-intercept, which when you're in this form, it's kind of the starting point of your graph. So that's the first thing we're going to do is we're going to figure out where we start the graph as far as where we plot the point. So negative 2/5 x, it seems to be missing something. There is a plus 0 on the end of this, which means our y-intercept is at 0. So along the y-axis, we make a point at 0. And then from that point, we move however the slope tells us to move. So this guy has a slope of negative 2 over 5. Slope is rise compared to run. So if you think about rising negative 2, that means you can move down 2, and then running positive 5 would be to the right 5. So just a reminder about your directions. Moving right is positive, moving up is positive, moving left or moving down are negative movements. So, like I said, we're going to move down 2 and then right 5. That is not 5. 1, 2, 3, 4, 5. And then I get to ruin this whole line by trying to make a line. I'm freehanding out a tablet here. Oh, you know what? That wasn't too bad. So before I finish the line and I commit to it, I just want to make sure that it looks appropriate. So we have a line that has a negative slope, so kind of sloping downhill, and it has a y-intercept supposedly at 0. I got a little off there. My bad. All right, this one. This is the same form, but now we have a y-intercept at negative 1. So on the y-axis, we draw a point at negative 1. And then from that point, we move with our slope, which is a positive 1 over 5. So if we think about moving positive 1 and then running positive 5, that would move up 1, right 5. You could also move negative 1 over negative 5, because we remember two negatives divided is really a positive value. So if you ran out of space, you could move left and down and left rather. Either way, you end up with this line. Ooh, missed him. Pretty close. All right, so a kind of less steep line, the slope is 1/5, that makes it less steep, but it's a positive slope, so it's going slightly uphill, and it's crossing the y-axis at negative 1. So that's us graphing lines in slope-intercept form. Doesn't really get any more challenging than that, so maybe I'll do one more. The next line has a y-intercept at positive 4. So on the y-axis, we plot our point at positive 4. And then your slope is negative 3 over 5. The tricky thing about slope is it's really easy to screw up, right? So the negative can either go with the 3 or the 5, but not both, because we just saw that two negatives would be positive. So if we're moving negative 3 over 5 for a slope, that means we're going to move down 3 and then positive right 5. 1, 2, 3, and then right 5. Now, the other way to move and still have a slope of negative 3/5 would have been up positive 3, but then left 5. Now, I'm going to run off the graph if I do that, but you can see how it's going to make that same linear relationship. And, oh, yeah, okay. Strong finish, terrible start. All right, so that's supposed to be a line. So those are lines in slope-intercept form. Now let's talk about, I should do one of these. I kind of forgot about this. So same form, same idea. We have a y-intercept this time at negative 4. Now your slope looks like an integer, but we know all integers can really be written as fractions. So your slope of negative 2 is really negative 2 over positive 1. So we can either move down 2 and right 1, or if you decided to put the negative with the 1, that would be moving up 2 and then left 1. But either way, watch what happens. So down 2, right 1, or up 2, left 1. You're going to get that same linear relationship. Kind of. Unfortunately, you have a teacher who can't draw. Oh, all right. Pretend that looks like a line. It's got a negative slope. It's going through the y-axis at negative 4. And it's going the right direction. So I feel like I did something kind of right there. Now let's talk about our special lines, the horizontal and vertical lines. So what if I asked you to graph the line y equals -4? That's a very special line because it doesn't quite fit the formula for y equals mx plus b. I mean, it kind of does if you think of it as having 0 x's. So in that case, it has a y-intercept at -4. Remember, this is the y-axis. And then a slope of 0, so it doesn't rise at all. It just runs to the right and left, which is why you get this horizontal line shape. That was supposed to be straight, my bad. So y equals -4 is a line through the y-axis at -4. So somehow in your brain you have to kind of connect those ideas. This is the y-axis, but it's crossing through the y-axis and creating a horizontal line. Now on the flip side of that, what about a line in the form x equals 2? Well, this really doesn't fit the y equals mx plus b formula. So now we got to think about, okay, here's the x-axis. If I go over to where x equals 2, and then I draw a line through it, okay, that was weird. I must have pressed a button. Okay, so now you have this vertical line that goes through the x-axis at 2. Just a little foreshadowing here. That is a line that has undefined slope. So it really doesn't fit that formula for slope-intercept form. But in your brain, again, you got to remember, okay, this is my x-axis. If I'm going to draw a line through it, it's a vertical line. All right, that should be enough review for you. You should be able to practice the practice problems on Delta Math, and eventually I think I gave you beautiful quizzes to test your skills on graphing. This is a big topic for us in algebra, not graphing necessarily, but using graphs of lines to do other things. All right, good luck.